Hello, math students. Today's lesson is called Sums and Differences of Mixed Numbers and Decimals. Sums and differences is just a fancy way of saying that we're going to add and subtract mixed numbers and decimals. Well, we've already done both of those things. Haven't we already added and subtracted mixed numbers? I think yes. And I think we've also done decimals. So what's different about today? Well, let's get into that. I've got 3 examples to show you. But first, I want to start with just a quick review of place value. So I know you've already learned this, but I'm going to need this in today's lesson. So we're just going to do a quick review. If I have a number, and we can actually pretend this is money, since it's the easiest to think of. So say I have this amount of money in my bank account, $243.79. Place value is as follows. The 2 in this number, that represents my hundreds. The 4 represents my tens. And the 3 here represents my ones. So we have hundreds, we have tens, and we have ones. Now beyond the decimal point, the very first number, the 7, beyond the decimal point, you'll probably remember this is our tenths. And do you remember what the 9 is? The second number beyond the decimal point represents hundredths. What a funny word to pronounce. It's like hundredths. So another way to read this dollar value is 243 and 79 hundredths. When you read it as such, you always use wherever you stop here, like we stop with the 9 in the hundredths place. So 243 and 79 hundredths. That's going to help us in just a minute. And of course, we could go further. If I had another value here behind the 9, that would be thousandths. Just like if I had a number in front of this 2, like 1,243, this would be our thousands. So hopefully that reviews that for you. Okay, let's get into our first example. So what we're going to do here, and I split the page into 2 columns because I want to show you how to do the same exact problem 2 different ways. So we're going to start here. We have 2 3/10 plus 5 3/100. Now, if we follow the steps that we followed in Unit 1 to add 2 mixed numbers, we would start by making them both improper. So here we go. 10 times 2 is 20, plus 3 is 23 tenths, plus 100 times 5, plus 3 is 503 over 100. Now we need a common denominator. So we could multiply 10 times 100 and get 1,000, but that's going to get really big. This is a case of addition where we have an LCM situation. So because we can grow the 10 to 100, we'll say that the LCM, the least common multiple of 10 and 100, is 100 itself. So I'm going to bring that down. Now, change colors here. Let's grow a 10 to 100. We can do that by multiplying by 10 on the top and bottom. So our new numerator, 23 times 10 is 230. And of course, 10 times 10 is 100. And this guy already has 100, so here we're just multiplying by 1. And 503 times 1 is just 503. Now that we have a common denominator, we can combine our numerators. 503 plus 230 Let's go off to the side here. 503. Oops, let me get that on the screen. 503, 230. Add those up. That's going to be 733. 733 hundredths. And now that's improper. So our final step is to long divide 733 by 100. We can't squeeze 100 into 7 or 73, but we can squeeze 100 into 733 7 times. 7 times 100 is 700. Subtract, and we get 33. So I'll say the final answer to this addition problem is 7 33 hundredths. Just a review. So why in the world do I have the same exact problem, if you look here, on this side of the paper? Can I get this answer faster? Well, we sure can, and that's what I'm here to show you today. When you have denominators in mixed numbers or proper fractions or improper fractions, when you see like a 10 or a 100, you should be thinking about place value. You see tenths and hundredths, tenths and hundredths. So if we would convert these mixed numbers to decimals instead of improper fractions, things might flow a little faster. So 2 3/10, that means we want the 2 in front of the decimal point. That's our whole number. 3 in the tenths place would be a 3 right here in the tenths place. Plus 5 3/100. 5 and is like the decimal point. 3 in the hundredths place. Well, to put the 3 in the hundredths place, we need something in the tenths place. So we're just going to put a placeholder of 0 there and put that 3 to the right. 5 3/100. Now, let's add these decimals. Let's stack them on top of each other so that the decimals align vertically. I'll just put a little 0 here as a placeholder. Let's add straight down. We have a 3, we have a 3, and we have a 7. And the way we would read that answer is 7 and 33. And where do we land? We end in the hundredths. So 7 33 hundredths. Watch my pen here. 7 33 hundredths. Which method was easier? Which method was easier? I would argue that the second method is easier. So when you're adding and subtracting with mixed numbers, keep an eye out for numbers like 10, 100, 1,000. Okay, let's try another one. Okay, our next one, same thing. I split the screen. We're going to take 7 1/5 minus 4 1/2. 2 times. First, we'll do it the old-fashioned way. We'll make them improper. So 7 1/5. So 5 times 7 plus 1 is going to be 36 fifths minus 2 times 4 plus 1 will be 9/2. Our common denominator, 5 times 2, is 10. We will take the 5 and multiply it by 2 to get 10. That means we have to take 36 times 2, which is going to be 72. Over on this side, we'll multiply the 2 by 5 and 9 by 5. So that's going to be 45. So 72 over 10 minus 45 over 10. Let's take 72 minus 45. We have to borrow and make this a 12. 12 minus 5 is 7, and 6 minus 4 is 2. So we'll go ahead and say 27 tenths. And then to mix it, we'll divide. 10 squeezes into 27 twice, giving us a 20 with 7 left. So let's finish this off by saying 2 7/10. Final answer. Okay, and that's just a fine way to do it. But let's look at it a different way. If we look at these denominators, 5 and 2, well, we already know they can both grow up to tens. Tenths. Tenths. Where's my paper? Tenths. So what if we do just that? What if we leave them mixed, leave our whole part here, leave this a 7, but change the 1/5 to tenths, 2/10, minus. Now 4 would come down, and let's grow this to tenths by multiplying by 5. Let's change these now because they have a denominator here of 10 tenths. Let's change them to decimals. So this would be 7 2/10 minus 4 5/10. Let's subtract them by stacking them vertically, decimal point aligned. Now we will have to borrow because we can't take 5 from 2. So let's borrow from the 7, make it a 6, and make this guy a 12. 12 minus 5 is 7. 6 minus 4 is 2. Final answer, 2 7/10. 2 7/10. So I want you to look carefully at your denominators to see which way does it make more sense to approach the problem. Now I have one last problem, and all I want to point out with this one is that when you have a problem like this, 4 1/3 plus 1 1/8, this doesn't really have the option to go the decimal route. You can't grow a 3 easily up to a 10 or a 100 or a 1000 by multiplication. Same with the 8. You just can't do it. So if your denominators of your fractions just don't lend themselves to growing to 10 or 100 or 1000, then just go the old-fashioned way. I won't go through this whole problem, but you would go ahead and make them improper. You would make this guy 13/3, and you would make this guy 9/8. You would get that common denominator of 24, and you would just proceed the way we always proceed with those. But look out for those other options. If you can make them decimals and make life easier, go for it. All right, thanks for watching today, and happy trails to you.